In this lecture, we will see what are the different types of fluid. The first classification is between the ideal and real fluid. So, what is an ideal fluid? Ideal fluid is a fluid which has got zero viscosity and also it is incompressible. That means its density will not change. A real fluid is a fluid which has got non-zero viscosity and also it is compressible. There is a difference between an ideal fluid and a real fluid. Now let us see different types of fluids. See, we have already discussed Newton's law of viscosity. So the fluids which obey Newton's law of viscosity is called Newtonian fluid. And fluids which does not obey Newton's law of viscosity is called non-Newtonian fluid. So what are the various non-Newtonian fluids? You can see some of the fluids here. First one is a dilatant fluid. This is called a shear thickening fluid. In this figure you can see that shear stress tau is in the y-axis and shear rate K is in the x-axis. So Newton's law of viscosity states that tau is equal to mu into du by dy. That is, du by dy is the shear strain rate, that is K here, and tau is the shear stress. So for a Newtonian fluid, viscosity mu, that is the slope here, it will remain unchanged. So viscosity will not vary. But take the case of a dilatant fluid. In a dilated fluid, when the shear stress is increased, you can see that the viscosity increases as the shear rate is increased. You can see the slope is continuously changing. So that means viscosity increases continuously. So that is why it is called a shear thickening fluid. So one example is the quicksand. Now look at another fluid, that is pseudoplastic fluid or shear thinning fluid. That means when you apply the shear stress, shear strain rate increases. You can see here the slope is decreasing. That means viscosity is getting reduced as shear rate is increased, as strain rate is increased. These are called pseudoplastic fluid, and example include blood. For Newtonian fluids, some examples are water and glycerin. Honey is also a type of Newtonian fluid. And then you have a Bingham plastic fluid. You can see that it will obey just like a solid up to a limit. After that, it will behave as a Newtonian fluid. Examples are muddy water or sludge. It needs an initial push. After that only it will undergo deformation. So these are the important types of fluid other than Newtonian fluids. For most cases we will studying here only about Newtonian fluids. There is another branch of study called rheology to deal with other types of fluid. For that means fluids which has got varying viscosity.